Hello, in this video I'm going to take a look at handling errors in Rust. I kind of skimmed through some of the documentation and there's quite a lot of it. So I think what I'm going to do here is there are 3 pages in the docs that I want to cover. The first one's really short, so it should be possible to get through that. And then I'll probably get halfway down the second one or something like that. So apparently the easiest way to terminate your program in the event of disaster is with the panic macro. I think I can supply a message here. Let's just write oh no. So I'll try this. Yeah, and it just says thread main panicked and my message is coming out there and it says I can turn on this environment variable to display a backtrace. Problem is I'm not sure how to actually turn on environment variables. I'm using PowerShell. Let's try, it's maybe like this, $env::rust backtrace equals 1. All right, so I think I've set that environment variable now. Looks like it's set to 1. So if I run my program with cargo run, yeah, wow, that works. So I do actually get a backtrace here. The docs actually say that by default, Rust is going to walk the stack backwards and systematically clean up the whole program before it quits. But you can add a config error to the cargo.toml file, which will stop it doing that and it'll just make the program crash out and quit. And then your operating system can clean up the memory and stuff if you prefer that. Now, apparently, one thing that causes a panic is if you try to access an element in a vector that doesn't exist. So let's create a vector. Let's say how do I create a vector? Let values equal, there's a vec macro, isn't there? I think I remember that. And that had square brackets in, strangely, 0, 1, 2. I think that would do it. And then I should be able to try to refer to something that's off the end of this vector. Well, the element at 3 will be off the end of the vector. Let's see what that does. Okay, yeah, so I've got a whole stat trace here because I just turned that environment variable on. And it says index out of bounds. Now, actually, at this point, there's one thing that I want to try out because I've been thinking about it. So if I access the element at 2, that should work. So let's say let x maybe equal that. And I think x comes back as an option. Let's print x here. So print, and then this is a bit of a detour, but there is something that I've been wondering about. So I don't think I can do that. Let's just run this. Oh, I can do that. Why did I think I was going to get an option? Yeah, it's get that produces an option. Now, what I don't understand is why so many examples have a ampersand there. Let's try it with the ampersand. It does the same thing. What happens if I try to change x? So if I say ++x, maybe, I can do that in Rust, right? And I print the vector. So let's duplicate that and try to print values. Will that actually change x in the vector? I probably have to make it mutable. Oh, it says not a valid prefix operator. Is there no ++ in Rust? Okay, well I can do plus equals 1. That's not going to kill me. So x plus equals 1. Right, let's try that. Cannot use plus equals on type reference to integer. That's fair enough. So apparently this is a reference to an integer. I should be able to dereference it with star, I think. Let's try this. X is a ampersand reference, so the data it refers to cannot be written. But that's just because I've not got mute in there. Let's say let mute values. Yeah, that doesn't help. That's mute in the wrong place. Let's try let mute x equal that. That doesn't help either. I want reference mute in there according to this. I want that. Okay, let reference mute x equal the thing in values. That doesn't work either. I'm going to actually try this thing here and see what that says. Oh, look at that. Expected type did not match the received type. Erroneous code examples. Well, that's not much help though, is it? That's just telling me what happens if I pass the wrong type to something. Okay, let's get rid of that. What happens if I put mute there? Can I do that? Cannot borrow as mutable. Consider changing this to be mutable. Let mute values. Yeah, so it wants me to change the vector to be mutable. I'll do cargo format here and I'll run it again. Oh, finally I got the thing working. And I think I actually did successfully increment it, didn't I? Yeah, because it's 013 in the vector now. So what I was wondering was, what is the purpose of this ampersand that normally goes there if you don't want this to be mutable? And it seems like it doesn't work without that. If I cut that out and then I run it, yeah, it's not working. So it's now getting an actual integer as far as I can tell, right? Type integer. But if I put that in and then I run it, now it's a mutable reference. So I suppose it just seems a little strange to me that this prefix before the values vector is actually changing the type of this variable, because it seems as though it's something that would apply to the vector. But this is a single value in a vector. So I guess this is kind of taking a reference of the thing that we're getting. That's the only way I can really understand this. So sorry for that detour. I just wanted to try this out. But it's interesting that it does work. I mean, it's pretty succinct code. We simply have to get a reference to the value from the vector. We're not forced to get a reference to the value from a vector. We can get it as just an integer. But if we get a reference of it, if we take a mutable reference of the value in the vector, we can actually change it. That is, we can change the value that exists in the vector. Okay, so for me, that's clarified quite a bit here anyway. So to get back to what we were looking at, if I do values 3, that is going to cause a panic. Expected round brackets found integer. What? Oh, you know what? I just missed off a semicolon, so now it thinks I want this to be the return type of main. Let's try this one. Yeah, that works and that causes a panic. Okay, so I'm going to comment this out. So now the Rust documentation goes into a massive long example involving opening a file. So I'm going to try out that example, and apparently we need to have an import here. Use standard : F, is it double colon? I think. fs : file. Now I can use this to try to open files. I will make this smaller, and I should be able to say something like let result equals file : open. And let's imagine that we've got a file called test.txt, which doesn't exist. Then this should return some kind of result in the form of a result option, which has two fields, OK and error for error. I will try printing this. Whether it can be printed or not, I'm not sure. Okay, so I'll try this. Yeah, it does actually print that, interestingly enough. So it's printing this option. I don't get OK because the file doesn't exist. So I get this error code, and that's carrying a message with it. Well, it's carrying some kind of code field, and also kind, which says not found, and message, which says no such file or directory. So that's pretty explicit. So this is the actual name of the constant in the... it's not an option. Am I calling it an option? I mean to say that this is an enum, I think. So we've got an enum with two fields, OK and error. So we're getting this error constant out of that result enum. And this can refer to different types of things because it's like a generic type. And apparently this thing is of type, the thing that this contains is of the type standard IO error, if I understand correctly. And this is what's printing out here. So I should be able to use let or if let or match to be able to check the different return results of this. So let's say let file equal, I think I want match here maybe, and then on there's some curly brackets. And if I match OK file, then in that case I can just return the actual file handle. And if I match error and error here, in that case I can take some other actions such as panicking. Let's say in there, file not found. I don't know what I could actually do with this file handle. There's a question. But let's see if this works. Yeah, clearly I messed that up. Yeah, I forgot the thing that I'm actually trying to match, which is result here. I want to say match result. All right, let's try. It wants a semicolon there. Let's put a semicolon in. I think that basically worked. We've got just unused variable warnings. So what I'll do here is go to the top, and I want to put in here hash exclamation mark allow unused to clear up my error messages a bit here. Although this is definitely useful. Okay, so if I run that, I think I've got the results that I want now. So I'm getting an error which is matching, and because it's matching, we're now panicking. Okay, so now it goes into a really complicated example, complicated for me anyway, where in a case of an error, it's then got like a sub-match to match different kinds of error. So let's try that. So what I want here instead of panic is I want to say match error.kind and put curly brackets in there, I think. And what are the different possibilities here? So we can have error kind not found, and then I can do something here. Otherwise, I want some kind of other thing here, and I can do print line maybe, and we'll just print this out. So let's print out other, maybe question mark. So if the file's not found, then I can create the file potentially. So what's actually going on here though? So yeah, if I try to open the file, the return value of this file open is going to be a result enum. That's either going to have OK or error, and both of these carry some extra information. In the case of error, then the error object that this error enum constant, or whatever you call it, refers to actually has a method called kind. And then we can check to see if that's error kind not found, or it's something else. For the moment, let's put in panic and not found. Let's see if this works. Match arms have incompatible types. Expected file found unit. Yeah, okay. So in this case, I'm returning a file handle. This is probably fine because I'm just panicking. But here I probably have to return something compatible with this. Unless I want to put a panic in there. Let's try putting a panic in. Actually, let's just change this to panic. I think that would then work. Use of undeclared type, error kind. Okay, apparently I need standard IO error kind up here. So let's put that in. Use standard IO error kind. Now does this work? Okay, yeah, that actually compiles and it's saying not found. So that's coming from here. But apparently what I could do is I could actually create the file. So here, instead of this, I could actually have another match and say file create test.txt, and then that's going to have its own match thing. Shouldn't there be a comma there? Maybe there should be a comma here. So in there I could say, okay, again we're going to have the same result being returned from file create. So I could match OK file, in which case I return file, or I could have an error. Do I have to give it a different name? I think I probably do. Well, let's try this. So in a case of error, I'm just going to do panic. Because of this, I've either got to return some kind of file handle, or else I've got to panic, and it doesn't really seem to be much other choice. So let's put panic and say cannot create file. I wonder if this works. This statement is not surrounded by a bow. I think that's just like scrawled off the side here. Maybe I can make, yeah, okay. It's not surrounded by a body. Should it have a body? I think it just needs it just needs a comma. So that should be comma, I think. Okay, now it runs and it's saying not found, no such file or directory. Where's this even coming from? So it's not saying cannot create file. It seems like it's doing this, but shouldn't I get file not found? And then it should try to create the file, I thought. So I'm just wondering whether I'm allowed to reuse these sort of names here. And I'm not. Let's maybe call this file FH for file handle. And here let's just call this E and see if that makes a difference. That does exactly the same thing as before. Wait a minute. It's not panicking though, is it? It's just saying no such file or directory. So it's not doing this, and it's not doing this. So where's this text coming from? Actually, I meant to call that test.txt anyway, but that's not going to make a difference. Well, I really feel baffled at this point. How is it that it's printing this? Where's that actually coming from? And why is it saying no such file or directory? And why is it not panicking? Wait a minute. I've already got this here. So that's what's actually executing, right? So this would make sense. I think I should have put some text in there. You know, one thing I don't like is that I've got hard-coded file names now. Isn't it possible I could do something about that? Like, could I say maybe let file name equal test.txt, and then couldn't I use that wherever I've used test.txt, so file name? This would work in any other language. Let's try this. Yeah, that seems fine. It's actually coming back with OK now, because I've now actually created the file. Let's have a look. ls. Yeah, there's test.txt. So could I also use this file name here? I should be able to do that, right? And then I want to say here something like open file name and get a result like that. And here I want to say cannot create file name. So that the errors should be a bit clearer now, because clearly what I've done is I've confused myself with lack of explicit error messages. Now let's run this. So clear, I'll do format and cargo run. Yeah, so as far as I can see now, it is successfully opening this text.txt. I'm going to call it test.txt though. Let's change that. Let's go back. ls. So what I want to do is remove this file and see what it does now. So what it should do is it should fail to open it. So this should fail and we get a result from it. It's not going to panic. It's going to print that and tell me what happened, hopefully. Then we're going to go into this match. So it's going to match either OK or error. And since this file does not now exist, it's going to do error. Then it's going to match the kind of the error. And it's going to figure out that, okay, what I've got is not found, so it shouldn't do this panic. And because it matches not found, it's going to try to do file create. And that should go okay. So I should end up with a file handle. I don't see anything in the documentation at this point about having to close the file either. Maybe it's like one of those resource acquisition is initialization things where when this goes out of scope, the file gets closed. I think before doing this, I probably should have looked up some stuff about file handling in Rust. But on the other hand, if I'd done that, I wouldn't understand the best way to go about handling the errors, which you've got to handle. Let's just try this. Yeah, so the initial error that I get is no such file or directory, but it should then have gone on to actually try to create the file. So it should now exist. Yeah, there's test.txt. And if I run it a second time, it shouldn't say this because now the file does exist. Yeah, and we've got we've got an OK result, which gives me the path of the file. It says I can read it and I can't write it. Okay, that's interesting. I'm completely wiped out from all this. I think this was the most rambling video out of this series that I've made so far. Now it does go on to say in the documentation that there are easier ways to do this, and clearly I need that because this is pretty bad with these I've got 3 nested matches here. It looks horrendous. It was horrendous to have to write it. So hopefully there is coming shortly an easier way to do that. But I think I'm going to leave it there for today. And I might have to look up some stuff about handling files, how I would write to a file and so on. But I guess if I continue working through this page, if it gives me an easier way to do this, that would really help a lot. Because I definitely don't fancy doing all this stuff every time I just need to write a file. On the other hand, I was complaining that handling Unicode strings in Rust is a nightmare, But at least 2 different people have pointed out that it's much, much worse in C and C++, which is the proper comparison, because you can't compare Rust to Java or Python because those don't create native binaries after all. And it's true that I'd much rather have to handle a string in Rust than handle a Unicode string in C or C++. Whereas with Rust you get Unicode out of the box. And in the same kind of a way here, I suppose. Okay, trying to open a file, catching the error, and then creating the file if it doesn't exist. This isn't exactly pretty, but would it be any different in any other language? I think it would be nicer in Python, but there you're not getting a native binary. And in Java, well, you'd probably get saddled with handling all kinds of exceptions, so I'm not sure it would be better in Java exactly. And apparently there are better ways of doing this in Rust, so we'll get onto that next time, I think. Okay, I hope you found this useful. Until next time, happy coding.